So in this question, you're given f of x is equal to integer part of x sine pi x. You're asked to examine the continuity and differentiability of this function on closed -1 and +1. Now as you see this function, it is a product of x and sine pi x, and this whole function is inside integer part. That is a composition of this function and the integer part function. So the function which is inside integer part is made of x and sine pi x. X and sine pi x. X is a continuous and differentiable function. Sine pi x is also continuous and differentiable function. Hence x into sine pi x will always be continuous and differentiable. So there will not be any problems of continuity and differentiability for x sine pi x as such. So if you take the integer part, so integer part is continuous and differentiable at all values of x except integer values. So integer part function is continuous and differentiable on all real numbers except integers. So if at all there are problems of continuity and differentiability for this function, they will occur when the quantity inside the integer part goes to an integer value. So you have to check where x sine pi x becomes an integer value. So clearly at x is equal to -1, 0 and +1. The value of x sine pi x goes to an integer. Hence, you just need to check the continuity and differentiability problems at these 3 points. So you don't need to check at all the intermediate points. That is, from open -1 to 0 and 0 to 1, you don't need to check the problems of continuity because the functions are nicely defined and continuous and differentiable in those intervals. So let us individually start at -1 and then 0 and go to 1. So what happens at x is equal to -1? So you're looking at closed -1 to +1. So let us first look at continuity. So what is limit x tends to -1 plus f of x? As we have seen, if you want to examine the continuity in closed -1 to +1, at x is equal to -1, you just need to be right continuous. You don't need to check the left continuity. And at x is equal to 1, you don't need to check the right continuity, you just need to check the left continuity. So limit x tends to -1 plus f of x is equal to limit x tends to -1 plus integer part of x sine pi x. So now look at what happens to x sine pi x on -1 plus. So x tends to -1 plus. If you take the real number line 0, -1 plus 1. So x is somewhere in the positive neighborhood of -1. And what happens to pi x? So the number pi x is slightly less than pi, right? Because x is slightly less than -1. Sorry. X is slightly greater than -1. X is slightly greater than -1. Hence, pi x is slightly greater than minus pi. Sorry. Pi x is slightly greater than minus pi. So if you take the quadrant diagram, so pi x is minus pi plus something. So pi x is slightly on the greater side of minus pi. So if an angle is slightly greater than minus pi, you get the angle in the third quadrant. So in the third quadrant is pi x. So sine pi x is slightly negative but very close to 0. That means sine pi x tends to 0 minus. So exactly at minus pi, the value of sine is 0. So minus pi minus, the angle goes into the second quadrant, you get a positive number. Minus pi plus, slightly greater than minus pi, you get a number in the third quadrant. So sine pi x is on the negative neighborhood of 0. So x is in the negative neighborhood of 1 and sine pi x is in the negative neighborhood of 0. So this is also negative, this is also negative. So something like x is somewhere like minus 0.99 into. So this is something like minus 0.000 so on. Minus into minus becomes positive. So the effective number is plus 0.000 so on. Right? So this whole number goes to 0 plus. Hence integer part will be equal to 0. Integer part will be equal to 0. And what is f of minus 1? What is the functional value at minus 1? So you just need to put minus 1 here. Minus 1 into sine of minus pi. Sine minus pi is 0 times minus 1 is 0. Integer part of 0 is exactly equal to 0. So the right limit is 0 and the functional value is also equal to 0. Hence, the function is right continuous at x is equal to minus 1. Right continuous at x is equal to minus 1. Next, let us go and check the continuity at x is equal to 0. So now, 0 lies in between the interval minus 1 to plus 1. So at 0, I need to check both the right continuity and left continuity. So limit x tends to 0 plus integer part of x sine pi x. So as x tends to 0 plus, x is in the positive neighborhood of 0. Pi x is also in the positive neighborhood of 0 because x tends to 0 plus implies pi x also tends to 0 plus. So the value of sine pi x is also in the positive neighborhood of 0. So x is in the positive neighborhood of 0, sine pi x is also in the positive neighborhood of 0. If you multiply these two, 0 into 0, 0 plus into 0 plus, you get a number in the positive neighborhood of 0. So the integer part of any number in the positive neighborhood of 0 is 0. And limit x tends to 0 minus integer part of x sine pi x is equal to. So x is in the negative neighborhood of 0. So pi x is also in the negative neighborhood of 0. So sine of pi x, because pi x is slightly negative, sine pi x is also slightly negative. So sine pi x is also in the negative neighborhood of 0 because pi x is an angle in the fourth quadrant. So pi x is slightly negative, means pi x is an angle in the fourth quadrant. In fourth quadrant, sine is negative. So x goes to 0 minus, sine pi x also goes to 0 minus. When you multiply two negative numbers, you get a positive 0. So 0 minus into 0 plus, if you multiply these two, the effective number tends to 0 plus. Right? The effective number tends to 0 plus. So integer part of some number in the positive neighborhood of 0, you get 0 as the answer. So right limit is 0, left limit is 0. And what is the functional value? F of 0. So if you put 0 into sine 0 is equal to 0. That means the functional value is also equal to 0. So right limit is 0, left limit is 0. The functional value is also equal to 0. Hence, the function is continuous at x is equal to 0. So finally, we are left with x is equal to 1. So at x is equal to 1, you just need to check the left continuity. So what is limit x tends to 1 minus integer part of x sine pi x. So this is equal to. So x is going to 1 minus, that is x is positive. slightly less than 1, that is 0.999, so on. And if x tends to 1 minus pi x tends to pi minus, right? That means pi x is an angle which is slightly less than pi. Slightly less than pi. That is, pi x is an angle in the second quadrant. Slightly less than 180 degrees. That is, in the second quadrant. So, sin pi x is positive and it tends to 0 plus. Because sin pi is 0. So, as this number tends to pi, the value of sin goes to 0, but on the positive side. So, x goes to 0.999, so on. Sin pi x goes to 0 plus. If you multiply these two, positive into positive is positive. 0 into anything is 0. That means the left limit of this function at x is equal to 1 is 0. So, what is the functional value? What is f of 1? Integer part of 1 into sin pi. Sin pi is 0 into 1 is 0. So, you get 0 as the answer. So, the left limit is same as the functional value. Hence, the function is left continuous at x is equal to 1. Hence, my function is completely continuous in closed minus 1 to plus 1. Next, let us try to investigate the differentiability of this function. So, let us try to investigate the differentiability of this function. So, let us check the differentiability at x is equal to minus 1. So, f dash at minus 1 plus. So, I just need to investigate the right differentiation at x is equal to minus 1. Is equal to limit h tends to 0 plus. Limit h tends to 0 plus. f of minus 1 plus h minus f of minus 1 by h. This is what I need to find out. That is equal to limit h tends to 0 plus. So, what is f of minus 1 plus h? So, you just need to put here. So, integer part of minus 1 plus h into sine of pi times minus 1 plus h minus. So, what is f of minus 1? So, we have already seen that f of minus 1 is 0 by h. So, let us carefully look at what this number is. So, just need to investigate what happens here. So, limit h tends to 0 plus integer part of minus 1 plus h. That is, so a number in the positive neighborhood of minus 1, and sine of pi times minus 1 plus h is minus pi plus pi h. Sine of minus pi plus pi h. So, what is sine of minus pi plus pi h? So, if you draw the quadrant diagram, so minus pi plus something is in the third quadrant. So, you have this is minus of sine pi h. So, sine of pi times minus 1 plus h is nothing but minus sine pi h divided by h. So, as h tends to 0 plus, pi h tends to pi plus. So, this sine pi h goes to 0 plus. Because h is a number which goes to 0 plus. So, pi h goes to 0 plus, that is in the first quadrant. So, sine pi h goes to 0 plus. We have a negative here, and minus 1 plus h is in the positive neighborhood of minus 1. So, this number is something like minus 0.999, so on. You have a minus into a number which goes to 0 plus 0.000, so on. So, this is going to 1. So, minus and minus gets cancelled. So, a number close to 1 into a number which is close to 0. So, this number effectively goes to 0 plus. So, this whole number effectively goes to 0 plus. So integer part of any number which tends to 0 plus is 0. So the numerator is exactly equal to 0. The denominator is approximately equal to 0. So exactly 0 by approximately 0 is 0. So f dash at minus 1 plus is defined and is equal to 0. Hence f of x is right differentiable at x is equal to minus 1. Now let us look at what happens at x is equal to 0. So what is f dash at 0? That is equal to limit h tends to 0 f of 0 plus h. F of 0 plus h, that is nothing but f of h. That is integer part of h sine pi h minus f of 0. F of 0 is 0 by h. So here, as we can see, if h tends to 0 plus, this goes to 0 plus and this goes to 0 plus. So both of these goes to 0 plus. Hence, the product also goes to 0 plus. So integer part becomes 0. So the limit is equal to 0. And if h tends to 0 minus, so this goes to 0 minus, sin pi h also goes to 0 minus. The product again goes to 0 plus. Hence, again you get 0 as the answer. So the right limit is 0, the left limit is also equal to 0. Hence, the function is differentiable at x is equal to 0. Hence, the function is differentiable at x is equal to 0. There is no problem. And let us look at what happens at x is equal to 1. So, at x is equal to 1, I just need to check the left differentiability. So, limit h tends to 0 minus integer part of 1 plus h sine of pi times 1 plus h integer part by h, because f of 1 is 0 again. So this is equal to, so as h tends to 0 minus, this is slightly less than 1. So this is something like 0.999 so on. So this is sine pi times 1 plus h. H goes to 0 minus. So this is slightly less than 1. So pi times a number slightly less than 1 is, so this whole number is slightly less than pi. So sine of a number slightly less than pi. So less than pi means in the second quadrant. So sine is positive. So this goes to 0 plus. So 1 plus h is going to 1 plus 1 minus, that is positive number. And sine pi plus h is also positive. So 0 plus times 1 minus goes to 0 plus. So integer part of this goes to 0 again. Hence, the value of differentiation is equal to 0. So the function is left differentiable at x is equal to 1, right differentiable at x is equal to minus 1, and differentiable at x is equal to 0. Hence, the function is also differentiable in the whole interval closed minus 1 to plus 1. So this function is both continuous and differentiable in closed minus 1 to plus 1. So that will be the answer to this question. Thank you.